Okay, I'm going to take the final exam and we will just discuss it as we go. So, question number one is an independent t-test. So, the IV is group, and the levels are male and female, and the DVs are these productivity scores. So, everything's good. The first thing you have to check is normality of the data. So, we're going to go to Analyze, Descriptives, and I prefer Explore. There's other ways to do this, but I prefer Explore. Come on, you. And productivity scores. And I'm just going to go by the histogram, which, histograms aren't perfect for SPSS, so don't trust them, but always trust normality plots. That's going to give us the Kolmogorov-Smirnov normality test. Dun, 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 dun. And so we got 30 people in it, nobody missing. There's the mean. And there's the normality test. So the Smirnov test says that this data, the DV only, is not violating the assumption of normality. There's the histogram. Again, that doesn't look really normal to me, but we're not going to go by that. So normality has been confirmed. So now we're just going to run the test. Dun, 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 dun. You can run it from either the output page or the data page. But this time we're going to go to Analyze, Compare Means, Independent Means, and it's going to give us the homogeneity variance test in this t-test. So that's where that's going to come out. So our grouping variable with this problem is gender and productivity scores. And let's just see what kind of options we got here. Nothing. And gender, I can't remember. Was it 0 and 1 or was it 1 and 2? Hold on while I check. Yeah, it was 1s and 2s. Okay, let's go back. Analyze, compare, independent to, and gender and productivity. And we got to define these guys 1 and 2. Continue, and we're good to go. So there's our t-test statistics. Hold on while I pull this up. All right, there's the means, 35 and almost 38. And it looks like there will be a standard there will be a significant difference in there because that's the difference between these two means is practically 3, and your standard errors are kind of small. So if you took a group standard error, it's like 0.8. So if you divide the difference 3 by the standard error, which is roughly the average of these two is about 0.8, it's going to come up to be greater than 2. So therefore, it's going to be a significant difference. But let's look at the test itself. And according to the first thing, we did not violate the assumption of homogeneity variance, right? The Levine's test did that for us. The t-test score was 2.33. Remember, we don't care if it's positive or negative. Without going into a lot of detail, we always take the absolute value of a t-score. And it was less than 0.05. So therefore, we have a significant difference between the productivity scores between the males and the females. It looks like the females were more productive, significantly more productive than the males. And this is how you would write it up. An independent t-test was used to see if there was a significant difference in productivity scores between the males and the females. The data did not violate the assumptions of normality of homogeneity variance. According to the output, there was a significant difference between the male productivity scores, and you put the means and the standard deviations, and the female productivity scores, same thing, means and standard deviations, and the p-value is less than 0.05. I probably should have put in there at the critical alpha level of 0.05, but if I forget it, I'm not going to knock you. So that's question number 1. Question 2, you're going to run a factorial ANOVA with no repeated measures. So when you hear that word factorial, that means more than one IV, and that means interaction. You got to look for a significant interaction. So let's go ahead and do this. You have your first IV is your school district, 3 different levels. Your second ID is type of delivery of the class, 3 levels. Your last IV is course length, 3 levels, and your DV is your state math scores. First thing you're going to do is check the assumptions of a factorial ANOVA. And the data has to be normal. By data, we mean DV. So let's check the DV and see if it's normal. We're going to go to Analyze, Descriptives, get in there, Explore. We're going to reset this bad boy, and we want state math scores. And again, we are just going to check the normality plots and look at the histogram, even though it doesn't really help there. Okay, so here is our output for the factorial ANOVA. So we got 21 people, and the mean is 516. Normality, oh, look at that. The same significance, 0.20. So that means we did not violate the assumption of normality. Interesting that it's the same number. But, and then there's the histogram. And again, that doesn't look very normal to me, but we're going to go by the Kolmogorov test. So the first assumption has not been violated. So let's go ahead and run our factorial analysis. We're going to go to Analyze, General Linear Model, Univariate, 1dV. And hold on, let me get this guy down here. All right, our dV is state math scores, and our fixed factors are district, delivery, course length. We're going to go down to options. We want overall. We're going to check the descriptives again. We want effect size and power, homogeneity variance. And we could run post hoc tests here, but I'm not asking you for post hoc tests. Okay, this one is going to be real basic. I don't want you to look at the simple effects. I just want you to make sure you can tell if there's a main effect of each of the IV and if there were any significant interactions between the IVs. And I'm assuming that, once you do see a significant interaction, you'll know to look at the simple effects, split up the different IVs into different levels. So let's just go ahead and run this. So this is how many are in each group. And there's the means of each group. So I'm scanning. So the standard deviation is really, really high. Okay. So the differences here aren't that big compared to the standard deviations. So, but let's go here. So the Levine's test says that we did not violate the assumption of homogeneity variance. Yay, us. And here is the money box. So the corrected model, this F is your omnibus F. Somewhere between all those different variables and all their levels, there is a significant difference between the scores somewhere. And you got a sky-high effect size. Partial at a squared is almost 100%, so it's 0.98. So let's look at district. And according to the test, there was a significant difference in the district scores. So there was a main effect of district. There was not a main effect of the delivery type. So it didn't matter if it was online or hybrid or in class. The course length, there was a significant difference. So in a nutshell, there was a main effect of district, which means there was a difference between the district scores. There was no main effect of delivery. So it didn't matter which type of delivery it had, and the course length, yeah, there was a significant main effect for course length. So now let's go down and check for the interactions. There was an interaction between district and delivery, a significant one, but nothing between the district course length and nothing between the three-way. You'll notice that the three-way interaction didn't show up on SPSS. I'm going to try to show you why here in a second. Hold on. So, being a curious statistics teacher, I'm trying to figure out why SPSS would not give us any information about the three-way interaction. And so I used this table, and I hand calculated the interaction sum of squares. And let me show you what I got here. Hold on. I used the Excel spreadsheet. Right, there's the data. And I hand calculated everything, the A, bracket B, all the interaction term. And here's the important one. When I got down to the triple interaction check, you'll notice all the zeros that it represented there was nobody in. So like this zero here. That means there was nobody in the second level of A, the third level of B, and the first level of C. And you'll notice it's full of them. And so I finally concluded that it had to be our sample size. Our sample size was not large enough. if you think about it, if we got a 3 by 3 by 3 ANOVA, that would create 27 little individual cells. And our sample size is only 24. So that is my conclusion, that if your sample size is too small in these factorial ANOVAs, it will not be able, the software will not be able to calculate the interaction or not with that. And I believe I did. I came up with a ABC number of that, and I got a giant F score down here. Can you see that? So I believe there was a significant three-way interaction. But again, we're not going there because I'm just trying to make this a short video and just a basic assignment to show me that you guys know how to run factorial ANOVAs. All right. So question number 2, in brief review, it did not violate the assumption of normality. Forget about the histogram. It did not violate the assumption of homogeneity variance. Almost, but not quite. There's your descriptives. And here is your output box that shows there was a main effect of district, a main effect for course length, no main effect of delivery. The only significant interaction that SPSS could determine was between district and delivery. And here's the write-up. We ran a factorial ANOVA with no repeated measures to see if there was a difference in test scores between the school districts, between the delivery types, and between the length of the courses. Okay, and according to the output, that there was a significant interaction. First of all, I'm sorry, there was a significant omnibus F. Okay. That tells us that we need to explore further. So when we get an omnibus F, that means that's just the beginning. You got to look deeper. So again, there was a main effect for district, F, blah, 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 blah. There was a main effect for course length, F, blah, 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 blah. But there was no main effect for delivery. So when there's no main effect, you put the exact p-value in there. Okay. I'll say that again. When there was no significant difference, you put the exact value for the p. The other ones, you do not. You use less than either 0.05, 0.01, or 0.001. Okay? So the only significant different reaction was between district and delivery. And since we know that delivery didn't have a main effect, then I would blame all of it on which district. So in other words, something between the districts is making the difference in these test scores come alive. So, and again, I put right in there that it looks like the sample size wasn't large enough to check for a three-way interaction. But it looks like it could have been. And again, it was probably the school district by itself, because there seems to be great differences between the school districts. So one of the districts must be much better at teaching math than the other school districts. And the second one was the length of the course. You know, of course, a 16-week course, you guys are going to learn a lot more than in a 5-week course. So that's probably where the interaction was. So that's it for number 2. Let's move on to the last one. So now the last one is a mixed ANOVA. In other words, you have a repeated measure IV, which is stress score number 1, stress 2, stress 3. That's a repeated measure. Everybody gets test 1, test 2, test 3. And then you have 2 IVs. One is which program they're in, either business majors or psych majors. The second IV is whether they got tutoring or not. So you're trying to decide, did the stress levels change over the 3 different stress tests differently for the business students as opposed to the psychology students? That's one thing you're looking at. The second is, did tutoring have any effect on their overall stress tests or not tutoring? That's basically what you're looking for. Okay, so we're going to run a mixed ANOVA. Here we go. Analyze general linear model. This is a repeated measures. So the factor, I'm just going to name it stress. You can name it time if you want, but stress, because there's 3 stress tests. And there were 3 of them. We're going to add, and we're going to define them. And it was stress uno, stress doso, stress treso. And our between groups were whether the program had anything to do with it or whether tutoring had anything to do with it. We're going to go down to options. And again, we're going to look for descriptives, effect size, power, homogeneity variance. And again, I'm not going to do post talks on you. And let's just see what happens. So these are your 3 repeated measures. This is how many people were in business, how many were in psychology, how many had tutoring, how many did not have tutoring. And there's all your means. So I'm scanning. It looks like you got some low ones here. 37 and 43. Standard deviation divided by square root of n. Yeah, it looks like you're going to have some significance in there somewhere. And so this is your multivariate test. What this tells you, this first number, means that, yes, somewhere there was a significant difference between the overall stress scores 1, 2, and 3. It doesn't delineate. It doesn't tell you if it's coming from the program or whether they're getting tutoring or not. It just says, yes, there's a difference somewhere between stress test 1, stress test 2, stress test 3. Okay? And it also says that, yes, there was a significant interaction between the program and tutoring, and there was another significant interaction between, get out of there, you double click, between the stress test and tutoring. So we're going to look at a different box. We're going to look at the test of within group variance. It should agree with this multivariate test box. So remember, sphericity, it was not violated, but with a mixed ANOVA, you don't look at sphericity. Okay, the between group design overrides the need for sphericity. So here's our test within subjects box. This is our money box. Money. So was there significant difference between the stress scores? Yes. There was a interaction between program and stress scores. Yes, there was. Okay. Was there a significant interaction between the 3 stress scores and tutoring? Again, yes, there was. And there was a 3-way interaction here. So something about which program they're in and something about whether they got tutored or not somehow affected their change in the 3 test scores. That's amazing. And we don't look at contrasts. And we did not violate the assumption of homogeneity variance for either of the tests, 1, 2, 3, right? That all looks golden. And we don't really need to look here because the between groups, it's not a between group design, it's a mixed design. So don't even look at this table. So let me check the answer sheet. I think I might have went and looked at some of these simple effects on my own. But again, it did not violate the assumption of normality. Did not violate the assumption of homogeneity variance. And there's all your descriptives. And there's your test of within subjects box. And again, you had interaction in between everything practically. And this is the write-up. So you ran a 2x2x3 ANOVA with 1 repeated measure. That was the 3 different stress tests to see if there was a significant difference in the stress test scores between whether they were psychology students or business students or whether they received tutoring or not. And the results were, yes, they were, you had an omnibus F right off the bat that showed that, yeah, there was a significant difference somewhere between those test scores. So here it is. You guys didn't have to do this part, but I did it for you. Since there was a significant interaction, I decided to look at the simple effects of program first. I basically ran 2 separate tests. I simply looked at the program. I looked at the psychologists, compare their test 1, test 2, test 3, and then I turned around and looked at the business majors, test 1, test 2, test 3. And then I did it with tutoring to see if there was a significant difference between the scores. And there was. So the business guys went down. Their stress went down, as did the psychology majors. Their stress went down. Interesting. So both of these stress tests went down regardless if they were in business or psychology, okay? And then I redid it for tutoring, right? I took out the program IV and I put in tutoring, and it was the same results. The tutoring stress scores went down, and the no tutoring stress scores went down. So it looks like the effective time, the 16 weeks of the class, they started out very, very stressful, but as time went down, everybody got less stressed out. That's basically what it was. And I think that's it. So what I'm going to do is I'm going to go over and look at your guys' tests, and hopefully it agrees with mine. If not, I will let you know. But that's it for now. Happy New Year. MGZ out. Sorry about the sniffling. I got a cold. All right, I'll see you guys soon. Stay safe. Again, MGZ.